Good morning, everybody. I'm Pete Coxon. I'm the head of geography. I was the science course director for 6 years and designed the modularised course that you've shown an interest in this morning. Geography is a member of the part of the Faculty of Engineering, Science and Maths, but it's also in the Arts faculty. So geography is a cross-faculty course, and it means that we study a whole range of different geographical methods. We teach the geography so that when you come in, you don't need to have done geography before, and if you have done geography before, it's obviously an asset and you find it that bit easier. But we teach it from scratch. We take an entirely new look at geography post-school. And the idea of this presentation this morning is just to give you an introduction to the subject, to what we cover in the modules that we teach. But there are people at a stand downstairs that can answer questions. I'll hang around afterwards if anyone has any specific questions about the geography course. And at the same time, we have staff personing a table down in the arts end as well, and there's a talk at the arts end. So I'll cover a range of different topics. Now, don't suggest for a minute that you try this. We do have a blog, a Facebook page for alumni, and etc. So we have a lot of information, and if you go to the web, you'll find all sorts of information about our courses. We teach you where not to have picnics. This is the fundamental rule of geography, is that you learn about a range of physical, human and environmental geography, and a lot of that is related to the modern world, and particularly to hazards, to planning for hazards. We've been deeply involved, for example, over the last 20 years in analyses of floodplains, of flooding, what should be done in terms of hazards from bog flows and from other miscellaneous environmental hazards that affect the Irish landscape. So we teach geography through Common Entry Science, which is TR071. All the information about TR071 is in this building down in the atrium. You can also take geography as a direct entry course called Earth Science, where you do a mixture of geography and geology. In the talk following mine today, after I think there's a half-hour break at 11 o'clock, quarter of an hour break at 11 o'clock, is on geology by Professor Camber from the geology department. That's an Earth Science course. It has a separate entry code, TR077. We also teach geography through arts, which is two-subject moderatorship. You do two subjects for the first 2 years at least, and then you can decide to specialise in one or the other. And the most common of these TSM or two-subject degrees would be sociology, economics, history, but that means you can also do philosophy, maths, German as the second subject. There's a table of these in the guidebook to the courses at Trinity. We also teach a direct entry course, Geography and Politics. And these two courses, Geography and Politics and Geography and Geology, are extremely popular with students. The course some of the modules are designed specifically for these students, and there is a set pattern or pathway. But essentially, if you come into geography, there's a wide choice of subjects that you can take throughout the 4 years of your study. In the first year, students take an introduction to physical geography, environmental geography and human geography. There are seminars, there are small group talk classes in one of these modules, and in the other modules, you'd be in a class about this size. There'd be about this many people attending first year lectures, up to about 120 people in geography modules in the first year. And if you take geography through science, you have to take either the physical or the environmental module. That would be 1/6 of your first year course. You would take a maths course, you might take geology, you might take chemistry, biology or physics. That will all be explained in the Common Entry Science degree programme lecture. But in geography, you can take half of your first year just in geography if you come in through the arts or the direct entry methods. I can explain that to you later. It's well explained on our web page as well. In the second year, there are again 3 modules making up half of your degree if you're doing pure geography: changing environments, changing worlds, and geography seminars. I'm going to show you some of the slides that I use in that changing environments course, and I'll show you the sort of work that we do. And in years 3 and 4, you specialise. We do a range of options, as you can see, from very much based on global change, climate change course. There are a couple of courses directly related to climate change. We even teach planetary geomorphology. We have a lecturer who has come to us from NASA who teaches about deserts of the solar system and has worked extensively in Tucson on the NASA material that's coming back from Mars. We teach geographical information systems, how to use computers and maps, coastal processes. On the human side, historical geography. We have an excellent lecturer in historical geography who will bring to life manuscripts, documents that allow us to look at the history of the Irish landscape through these resources. We also teach on African and Chinese development, and we have lecturers who are experts in the field of environmental governance, on waste management. They're deeply involved, for example, with Science Gallery and planning for the Science Gallery displays, because geography is a key element of many of these topics. Geography wraps over many subjects, and even if you only take geography in first and second year, you'll get a more holistic idea of the way the environment and the world works from those subjects. We run field trips. This is a handful of the field trips that we've run. We don't run them every year. We don't run them for all groups, and it depends which part of the world is stable at any given time as to where we can go. But I've taken student groups. The third years all go to Mallorca. They all get the chance to go to Mallorca. This is a field trip held in September at the beginning of the third year and teaches skills to students who want to do projects in geography. You all do a project in the third year if you're doing full geography, and that's a research project. I've taken students to the Himalayas twice. We've been to mainland Spain. In the year of the foot and mouth outbreak some years back, we couldn't do field work in Ireland, so every student who'd signed up to do a physical geography project was taken to Iceland, and we did the field work there instead. And in fact, in a second foot and mouth outbreak, we went to Spain. We had to simply leave the country and do the project somewhere else because we couldn't go out onto farmland. Students have been to Kenya in smaller groups, and you can see here surveying techniques. We also carry out field and laboratory exercises. There are laboratory classes in third year and in fourth year in which you're trained in a range of classic physical geography techniques. Here students are sieving materials to judge the size of the grains within a material, and here you can see students being shown how to measure the velocity of water in this river. This didn't go particularly well because this river is deep and fast, and you can see he's on a safety line. We tend to do it in much more tame rivers like the Dodder or the Dargle at low flows, which are not quite as extreme as this, a tributary of the Indus in Kashmir, not the safest place to go measuring river discharges. In terms of rivers, processes, we teach a whole range of topics. This should be a video. This is the headwaters of the Yellow River in China, and these are tourists taking a look at this river, and you'll see that we give you lots of advice like where not to stand on eroding riverbanks. You can see why the Yellow River is called the Yellow River. This is where not to stand, and you don't lean out to take pictures. We teach you about sediment transport, we teach you about the processes that operate within rivers, and we teach you about the risks associated with rivers. But again, we tend to do that a bit close to home. Most of the time, this is the Dodder at the dropping well. And you can see this rhino is extremely useful for gauging the level of water in the river. That's it at low flow, that's it at Christmas, and that's it completely disappeared during a flood. And this flood here, pictured from 2011 during snow melt, caused severe damage along the River Dodder. And in fact, you can see here debris banked up against the Dropping Well pub. This is a protective wall that was built about 10 years ago. And the lump of masonry in the car park is the wall of the car park that's been washed away. And we calculate, we took a student group there that week, and we measured this block of masonry. We can calculate the velocity of the water from the size of that block, and we can then calculate the risk to any structure that's in the way. But a good tip is that if you're going to the Dropping Well during a flood, don't leave your car in the car park, because the next morning it might have travelled without you downstream. This is October 2011, a couple of days after the flood. And the 2 previous days there had been 105 millimetres of rain, which had left this micro, I think, from Cork upside down on the weir, down by the block of flats, by the next bridge down from down in Milltown, down from the Dropping Well pub itself. 105 millimetres of rain, well, that's Dublin only gets 700 in a year, so if you get 105 millimetres of rain in 2 days, then you're likely to be heading for a catastrophe. That's not unusual. These types of flash floods are becoming more common. Intense rainfall events are more common. We analyse that from a whole range of data. We use Met Éireann data, we use data from the UK Met Office, and students doing their project work may well look at the likelihood of flooding in the future in a certain catchment. But here you can see stacked cars. In fact, the stacking of these cars even tells you which way the water was flowing. So we can calculate not only the volume of water, but we can calculate from fossil deposits. You don't get many fossil deposits of cars, but it's not impossible that you would, and we can calculate the velocity and discharge of a river. We also analyse climate change over long periods of time, and one of the lines of expertise in the department, in the scientific end of things, is to reconstruct environments of Ireland in the past. We know that only 17,000 years ago the Wicklow Mountains looked like this. This is Alaska today, or a couple of years ago, and we know that Ireland looked exactly like this. We also know that East Galway 5 million years ago looked like this. It was a swamp cypress forest, and we know this from analysing cores and information that we can collect from drilling down into deposits in these parts of Ireland. So we can reconstruct landscapes of the past. This, for example, this floating ice in this picture is coming out into a lagoon. This is a lagoon on the southern side of Iceland, and we know that during the end of the last glaciation, as the ice broke up off the coast of Ireland, it produced similar lagoons of a greater size. Donegal town is in here, Sligo is in here, this is Glenade, I think, or Gleniffe, Glenade or Gleniffe. This is where Yates's church is. So this is Yates's grave is on this medial moraine here. This is Knocknarea, the Ox Mountains, Achill is out here, and this shows us the ice streaming offshore at the end of the last glaciation. And these are digital maps that we have taken off the web, and you can see the moraines underwater in Donegal Bay, showing us the extent of the last glacial ice. This is the type of thing that you'd come on to study in the 3rd and 4th year. You'd get an introduction to this type of thing in the 1st year. We look in detail at changing environments over time, and you all know that the environment at the moment, the global environment, is changing. The part of the world that's heating up the fastest is the Arctic in relative terms. And if, when teaching this course, when I arrived in Dublin in September 1979, there didn't seem to be any threat to the Arctic ice. By 2007, the Arctic ice, as you can see, has retreated dramatically, and by 2012, we can navigate through this channel. This is Alaska, This is Canada here. We can navigate through this channel here from Greenland, and this has had intense impact on the way that we view this Arctic area. We think of it as, the ice is melting, the Earth is warming up. As this snow disappears, the planet will warm up even more because the snow will not be reflecting radiation back into space. But this has caused geopolitical problems as well that interest human geographers, because this has meant that you can now sail boats through this passage. Can you collect oil from here? Who owns the islands here? Who owns the territory between these places? Has caused a geopolitical tension in this area and has caused it to be strengthened in military terms. At the other end of the planet, we see the Antarctic ice. This is the Antarctic ice on the Larsen ice shelf in February 2000. And if we run through a quick sequence here, January 2002, we can see this Larsen ice shelf begins to break up, so that within 2 to 3 months, the ice shelf catastrophically collapses, and we get the discharge of 2,600 square kilometres of ice. If that ice was 500 metres thick, we can calculate it's billions and billions of tonnes of ice. And to put that into context, we can superimpose a map of the east coast of Ireland from Waterford up to Howth, and that gives you an idea of the problem of the scale that the Earth faces in terms of changing climate. It's very dramatic indeed. And in fact, at the moment, we tend to deal with media coverage. This is unseasonably warm weather in November 2003, but of course this very dramatically changes to August 2008, and we see flash flooding, intense rainfall events caused by intensification of climate systems in the North Atlantic. We see this in human terms as well as media terms. This is me and my car in Goatstown Road in 1983, and those of you that have come here slightly older than the others will remember the 1980s were a complete disaster. If it snows now, if it snows in the next couple of weeks, which as I'm going to show you, it almost definitely will, then if it snows in the near future, at least the supermarkets are stocked, the trucks are bigger, we can get around a bit easier. In 1983, I advised my first year students that if there was more than 2 centimetres of snow, to go back to bed, because no one was going to get in here. The first bus on the road would slide across the road and block everything. Things have slightly changed from 1980s, but not by much. And in fact, in 2010, we had a reversion to this type of weather. This is January 2010, and of course, by the end of 2010, start of 2011, this repeated itself. And there was even an igloo built in one of the squares of Trinity College by the engineering students who had a cider party inside the igloo. This is typical of student behaviour. And it's one of the things you can almost definitely get involved in if you wish, and it snows, but it's a very good igloo actually. I was quite impressed by that. That is a couple of years ago. But this type of strange weather phenomenon, which we do study, is not unusual. This is Dundrum in 1963, caused by a flash flood event, about 180 millimetres of rain in one flood. And remember, Dublin gets 700 a year. And this is water pouring from the old railway line at the Dundrum Bridge, and the Lewis line now runs across here. This is 1963. There was great damage during this, and as I say, by 2010, we get this revertance to the BBC telling us that global temperatures hit a high. Well, Rathfarnham didn't feel like global temperatures were hitting any high. So why is this happening? Well, it's happening because of a climate system in the North Atlantic, the North Atlantic Oscillation, and if this North Atlantic Oscillation dips, it's cold, and if it rises, it's warm. This is a very simple way of looking at it. It's not quite as simple as that, but the 1960s, those of you that remember the 1960 weather, 1963, I was blocked in my house. 1963, it snowed on New Year's Day, and the snow was cleared from our street at Easter. So this is a sort of winter we haven't experienced since the North Atlantic Oscillation was in this negative mode. The early 1980s, there's the North Atlantic Oscillation, there's 2010, this is 2014, and it's dipping down here. So if you want to put a bet on a white Christmas, it's a good bet, okay, this year. This is the graph you'd use, but I will warn you that as with stocks, this graph is likely to go up and down at any minute, and I can't guarantee anything. Although 2 years ago, I did win 50 Mars bars by predicting this. I should have gone to the bookies instead. You get better odds. This is what's actually happening. This is the North Atlantic Oscillation in a positive mode, the 1990s. Most of the students we had in the last 5 or 6 years, if you spoke to them about scraping the ice off a car windscreen, they just stared at you like you were nuts. But you didn't have to do this in the late 80s, early 90s. I remember whole winters when there was no snow or ice at all. In fact, the temperature didn't go below zero. And the reason for this is the North Atlantic Oscillation. The low pressure is where it should be over Iceland. The high pressure is where it should be over the Azores. And we get warm, wet air coming from the west. If that goes negative, then this high pressure builds out in this direction and the wind comes from the east. So it's moving negative at the moment. It does this on a 20-year cycle. It's moving negative at the moment. And that means that, did someone tell me that there's a headline in the paper, the beast from the east is on its way -8 degrees centigrade over the next week. May happen, may not, we don't know yet. This is caused when these winds stop reaching us and our wind comes instead from Siberia. We study this in detail. On a longer term view, geographers of course are interested in climate change and what's going to happen into the future without just predicting short-term events. And probably the scariest graph that one can reproduce without any exaggeration. This is not ClimateGate, this is not fudging any of the data. This is the concentration of carbon dioxide in parts per million. Here, 280 has been the classic level of carbon dioxide in the atmosphere up until the onset of the Industrial Revolution. 1750, Britain gears up, starts burning large. Of course, this had happened earlier in other parts of the world, but gears up for the Industrial Revolution in 1750. And you can see the impact at this, so that by 1850, CO2 has risen by 10 to 15 parts per million, and the latest data show us that it's just hit 400 parts per million, the highest level of carbon dioxide in the atmosphere for 6.5 million years. So we have to predict what's going to happen next from these data. And the people who built this Asda supermarket haven't really predicted too carefully. Not Asda's fault. But they haven't predicted too carefully. This is a raised beach, raised marine platform from the last interglacial 120,000 years ago. And this is what happens if the Greenland ice sheet melts, which it's doing. 6 meters of water will be released. I won't go into too much detail about the Antarctic ice. The Antarctic ice is stable, it's cold, it's at -30, so the Antarctic ice is stuck. If it wasn't, we would be under 50 metres of water here. So most of Dublin would be in trouble, most of the big cities in the world would be in trouble, but the Antarctic ice has been stable at least for the last 800,000 to 1 million years, because we have cores through it that show us that it's stable. But if the Greenland ice melts, this is the volume of water that's dumped into the world's oceans. We study this through a variety of methods, and this again is a project undertaken as a master's thesis by a student. And what you can see here is it's looking at submerged peat deposits in the southwest of the country, down near Skibbereen. Trelong Bay is down near Clonakilty Way in West Cork. And here you can see us drilling into these sediments with gusto, and it's quite hard work, but we're taking cores from these submerged peats and we're analysing the change in global sea level and local sea level from this type of information. So we use state-of-the-art equipment. We train you to use state-of-the-art equipment. We have equipment that can measure height, distance, and so on with extreme accuracy. We measure rivers to see when they flood. We have a student who's forgotten their wellies here, showing why you listen to the lecturer when they tell you to bring wellies. Although wellies wouldn't have done much good there because she's been sent out into deep water, but still. This is us measuring various features in the field. Here, just in Trinity, being trained how to use this state-of-the-art GPS system, quite different to the ones that are fitted in cars or handheld machines. We have access to a range of digital information that we can superimpose data on. These are false colour images of the Dublin mountains looking towards Dunleary Harbour here and the wall, the North Wall, and this is satellite data that we've draped over digital information. And as I said, we can use this type of information. Remote sensing information. This remote sensing information has come from millions of miles away, and here it's been used to map dune fields, for example, on the surface of Mars, and we can understand the climate and the weather systems on Mars from this. We can also understand, for example, in collaboration with historical geographers, with people interested in what happened in the past, it's been possible to map, for example, the ownership by religion of parts of Ireland in 1640 and then in 1670. And we see this dramatic change in land ownership and in where people are living from different religions by looking at the results of the Down survey and putting this information into a geographical information system. We can then find out the percentage land change, the land ownership change. We can see how fast this was occurring. We can put rates on it. And there is quite an impact of this type of study within the digital humanities, and this will feed into historical geography and into parts of human geography. We have students who've studied as part of their undergraduate dissertations, their projects they carry out in the third year, the development, for example, of biofuels, one of the big issues in modern geopolitics. Do you grow crops to feed people, or do you grow crops to add the fuel to diesel to make our petrol consumption, diesel, petrol, oil consumption drop? Back to hazards, we've got a nice hazard here. This is flooding the Gort lowlands. Floods nearly every third or fourth year. And this is Leenane on Killary Harbour. This is Killary Harbour here. Leenane sits about here. And in 2007, everyone was driven to the pub because there'd been a big rainfall event midsummer and the side of the hill had collapsed, and this collapse had caused large-scale landsliding and flooding in the Leenane area, and you can see here these holiday houses are not particularly well sited. There's a serious hazard from landsliding here, and in fact the bridge at Leenane was washed away. This is Hamilton's Bar just before and just after this flood, about a couple of years before. And this bridge had to be replaced as a matter of some urgency, because if you know the area, it makes it very difficult to get up the west coast without that one single bridge. And that bridge had survived from the 18th century, and yet it was washed away in a single flood, very high intensity flood, and these floods have become increasingly common. This is a bog failure caused by a civil engineering project placing in roads to access the top of a hill to build a wind farm in Galway, and we were sent and analysed some of this area. And this is the Polytomish bog slide, that these ribbon development of housing here overlooking this bay. This is where the Shell gas pipeline comes in along here in Belmullet. And on this side of the valley, an intense rainfall event, hundreds of millimetres of rain in a couple of hours, and the people here were extremely lucky that this particular event missed the houses. Well, we've been mapping these events in the last couple of years. We've gone out with students, a couple of undergraduates and a few postgraduates, and we've been mapping the location. You can see the little white marks on this digital map here, mapping the location of these events so that we can tell county councils, the Geological Survey, where they're likely to happen. Where don't you build? Produce a hazard map to tell people where not to build. So the sort of projects we do are very applied. Some of our students do extremely applied work. Sediment coring in Africa to see how vegetation has changed over the last 7,000 or 8,000 years. Here, a student mapping vegetation in Iceland. This is an undergraduate student of ours, a visiting student. She came on that Iceland trip, and her project, her undergraduate project, was published in a major journal, showing the rate of retreat of the Icelandic glaciers just from the plants that grow in front of them. So it's more than just names of maps, it's more on maps, it's more than just where cities are, it's more than just the names of rivers, and it depends on your geography teacher at school. Some of you will love the subject, which is presumably why you're sitting here listening to me. Some of you never want to see it again. But I tell you that at university it's quite a different subject to mainstream in most schools. So we teach, we don't just learn things off by heart, but we actually produce applied projects for students. So those are the courses, and as Michael Palin, the ex-president now of the Royal Geographical Society, says, you can travel the seas, poles and deserts and see nothing. To really understand the world, you need to get under the skin of people and places, learn about geography. And Michael Palin has been a great promoter of geography through his various trips around the world, and the guy is really smart and has produced some marvellous work giving us insights into the world. Jobs, well, this is a run of jobs that just taken instantly off the web. Occupation related to a geography degree are listed down here. You can see some of these are from Ireland, some are from the UK, but the jobs on the whole are in these fields and areas. It depends what you study when you're a student. No degree in here, and I'm not going to get too philosophical, but no degree. Do what you're interested in. That would be my first piece. Been here 35 years. Study something you're interested in. Engage with it. Engage with the people who are teaching you. Do a project in something you're interested in, and find an application for it. And this will make you far more employable than doing something that you don't enjoy, don't want to do, or can see no reason for doing. So you get a lot more information about us on the web. So our website, we're in the School of Natural Sciences in Trinity. We're also in the Faculty of Arts. But if you go into the geography webpage, you'll find information about all the modules that we teach. There is a desk downstairs that's personed by geography students and geography staff. So that's more or less it. And thank you for your attention.